look at one more case that's actually kind of special. This next one is we've got x is greater than or equal to -3. Just like we did in previous sections, if we only have an x or we only have a y, we have one of our special cases. Well, if we've only got the x, we're looking at box because of the x in it, which means I'm looking at the V means a vertical line. Well, vertical lines only have x's in them, and they only cross the x-axis. So I'm going to have a vertical line, which means going up and down, crossing the x-axis at -3. So here is -3. I'm going to be crossing the x-axis there, and the line goes up and down is what a vertical line looks like. Be careful. What kind of vertical line do we have? Well, according to this one, we have an equal to, so it will indeed be a solid line because of the equal to. So I'm going to draw a solid vertical line here at -3. Okay, now the last part is still the same. We're still going to test a point. You get to pick it. It just can't be on the line. So again, I'm going to choose my favorite point 0, 0. Because it's not on the line, and let's test it by plugging it in. Well, our original inequality was x is greater than or equal to -3. Notice that there's only an x to plug in. Our x was 0, so I can replace that x with a 0. This now gives me 0 is greater than or equal to -3. Is that true or false? Well, 0 is bigger than -3, so that's true. So that means that is a working point. Because 0, 0 does indeed work, it means that we want to shade that side that 0, 0 is on. Because it actually works. So we'll shade that entire side. And that's it. Next idea in this section, the last one is, what if we want to look at two graphs at the same time? Well, what we would do is we'd take one graph and graph it. We'd do like a little mock-up and graph one graph first and do its shading. And then on the same graph, we would do the second graph they were asking for and do its shading. But this is what I would say is kind of what I call a mock-up. That's not actually what would be your final answer. If you're asked to graph two graphs at once, your final answer is only going to be this part, your overlap of the two shaded areas. You'll still have both lines no matter what, but the only part that should be shaded is this part, what's called the overlap. So this is why I call this graph on the left an overlap, because it only gives you an idea of what your answer is. Your final answer should only have the shading of the overlapped region, where your two graphs overlapped. Nothing else should be shaded in your final graph. So the idea is when they give me any examples that have two graphs, I'm going to actually do, or when we have two graphs like this, is that I'm going to do a graph off to the side before I do my final answer graph. So that I can see what's going to overlap first, and then only on my final graph do the overlap. So let's take a look.